Assalamu alaikum. My name is Ruja Rashid.
And I am Anhar Hussain.
We are going to present a topic related to data structures, that is
SkipList.
SkipList. It is a data structure based on randomized algorithm, as we all studied before about searching algorithms like linked list and tree, which require more time for the operations like insertion, deletion, and especially searching. To overcome these drawbacks of linked lists and to do these operations faster, Bill Few invented SkipList.
For the representation of a skip list, first we have to build a skip list. To make a skip list, you start with a list that you already have. So here we have a singly linked list containing elements and the elements are sorted. We will call this list L0. At the head of every list, we create a dummy node that is called a sentinel. Now from L0, we are going to make a list L1. SkipList is a randomized data structure. Whether to grow a node's height, we flip a coin for each element, and if a coin comes up head, that element will get promoted into L1, and if it tails, so it will not get promoted to L1 and stay in L0. Now let's begin with the first node, that is 3. Flip a coin. It happens to be the head. Since it is head, so 3 gets promoted. Again flip a coin. It's heads. 7 gets promoted. Flip a coin for 9. Yes, it's heads, so 9 gets promoted. Flip a coin for 10. It's tails. 10 will stay in L0. Flip a coin. 16 gets promoted. Coin toss for 21. It's tails. Coin toss for 24. It's heads. Coin toss for 32. It's tails. So 32 will stay in L0, and here we have a new list L1. Next, we are going to make a list L2 from L1, and we are going to do this by tossing a coin for each element in L1. So flip a coin for 3 in L1. It's heads. So 3 gets promoted into L2. Again flip a coin. It's tails. Coin toss for 9. It's tails again. Coin toss for 16 in L1. Yes, it's heads. And again flip a coin. It's heads again. 24 gets promoted. And we have L2. And we keep going to make L3. Similarly, we flip a coin for each element in L2 and we get the list L3. We will continue flipping a coin for elements in L3, and from that we get only 24 in L4. Now for L5, flip a coin. Since it's tails, so L5 is empty and we stop here. We have finished building a skip list. This is the representation of a skip list which has 5 layers: L0, L1, L2, L3 and L4. So there are the 3 basic operations of skip list we are working on: search, insertion, and deletion. As we know about linked list, search operation takes more time, which is O of n, and for searching it in lesser time, we use skip list and make it in O of log n time complexity. And similarly for insertion and deletion, we use skip list to reduce the time complexity.
Firstly, we are looking into the working of search operation. Look, here is a representation of SkipList. Let's see, we are searching for key 10. We start from the topmost level of the sentinel, that is L4, and go right. Here we get 24, which is greater than 10. Go down to the level L3 and search for 10, and again we get the greater element. Further go down to level L2, go right, and here we get 3, which is smaller. So we have to go further right, we get 16, which is greater. Go down from the element 3, go right, we get 7, the smaller one. 9, again the smaller one, and then 16, which is greater than 10. So this shows that our key 10 will lies between 9 and 16. Lastly, we will go down from the element 9, search linearly, and yay, we found the key 10. So this shows that we skipped so many elements from different level of linked list and found our desired key within the time complexity of O of log n.
Now, as we know, SkipList is a data structure and we can do much more than just search. So let's talk about inserting an element into a skip list. To insert an element into a skip list, first we have to search the position in L0 where the new element has to be inserted. Let's insert the key 12. First, find the position for the key. That is basically the search operation. By searching the position for our key 12, we find the position for 12 between 10 and 16. Because our key is greater than 10 and less than 16, so we inserted 12 in L0. As we know, each element has different level of it, and for this we use randomize algorithm, which says flip a coin. If heads, promote to a higher level, and if tails, stop at that level. And here 12 gets only 2 heads and our element 12 stops at level L2.
Deletion. Deletion in a skip list is easy as compared to searching and insertion. So if we want to delete 9 from this, firstly we have to search for its position and then delete it from all the levels, and after this we have to connect its previous and the next pointer with each other. So in L0 connect 7 with 10 and in L1 connect 7 with 12. Now, we will see the advantages and the disadvantages of skip list. Advantages. As we already seen that searching can easily possible in less than O of n time, that is in O of log n. Similarly, we can easily jump into the middle of the list by skipping most of the elements. And on the other hand, skip lists have one and the most important disadvantage, that is it take more memory for the sake of reducing time consumption.
So at last, what you can conclude from this picture? Yes, it shows skip list is an extended version of linked list and all the working of skip list is linked with linked list. We mostly use linked list, but depending on different problems we want to solve, we could apply skip list to achieve significant speed up. Thank you.